Okay, now let's start a new lecture. And these two data structures are probably the most important. I mean, NumPy is the most important, definitely, and Pandas is based on NumPy. I'm going to start with Pandas because it's simpler to understand as a first third-party library, and then we'll go into NumPy. But before NumPy, I'm going to make also a refresh on linear algebra, try to map the relation between linear algebra and NumPy in terms of matrices, vectors, and multidimensional matrices. بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so this is now, we move to chapter 3 in the course Introduction to AI in Data Science. And today we're going to start with the Pandas Data Structure, which is a third-party library, pretty much useful in data analytics and data visualization. In the previous lectures, we have introduced Python data structures, the built-in data structures including list, tuples, dictionary, and sets. And today we're going to, so these are useful, but they are not comprehensive to do advanced data analytics or advanced computation, especially in deep learning and machine learning. We need a very efficient data structures in terms of speed, in terms of memory management. NumPy is made for this, and several other libraries are built on top of NumPy, including Pandas. So as already mentioned, in this course I'm going to start with Pandas because it's more intuitive to grasp. It's a higher level library that is built on top of NumPy. It's mainly used for data analytics and data manipulation and also data visualization. So what is Pandas? It's the name of the library that is designed for data manipulation analysis. So what does it mean, data manipulation and analysis? It means, for example, if you have tabular data, like an Excel sheet, and like an Excel sheet, for example, if you have an Excel sheet, you can do multiple type of data manipulation, like, for example, calculating the average of a column, or making data visualization, calculating some different type of descriptive statistics. So the same thing, we can do it for Pandas, with Pandas, by, for example, importing data source like CSV files or Excel sheet or even SQL tables, and manipulate this data and do advanced analytics. So this library, as already mentioned, is built on NumPy, the most important data structure in Python that leverages high performance computing and arrays. And Panda is basically efficient for working with structured data. So structured data, they comes into tabular form. They have rows and columns. This is what we call structured data, as we already introduced. And simplified tasks like, for example, data cleaning, data exploration, and data transformation. Data cleaning, because most of the data that comes from real-time application, from real-world applications, they contain a lot of noise. Some data is missing, some data is incorrect. So we need to clean the data before doing any kind of data analytics. We already presented this when we talked about the business life cycle of a data science project. Data exploration, it means, for example, calculating descriptive statistics like the mean, the variance, or confidence intervals over data. And data transformations, you can do different type of transformations, rows and columns, and so on. And this is suitable for small and also large data sets manipulations. So the advantages of Pandas, it simplifies complex tasks like merging, reshaping, and filtering data. It's highly flexible. It can handle missing data and also time series forecasting. It supports custom data transformation using lambda function, like using map and reduce,
ستحتاج إلى فتح قفل الآيفون
the different functional programming tools that we have introduced. So also another very important advantage, you can get the data sources from different formats. You can load data from a CSV file, from an Excel file, from an SQL, and also from JSON. We're going to go through all these different types. And it allows to handle large data sets efficiently with chunking and memory optimization. So there are two main data structures that are defined in Pandas. The first one is what we call the series, and it's one-dimensional array. It's like a vector. We call it a series. And more general, we have data frames with our two-dimensional table data structure. Okay, they are organized in rows and columns. And basically, we can transform a data frame into a series. If I select a row or column, I can transform it into a data series. and perform equations or data manipulation on the data series if needed. It has several functionalities. For data missing, we can, for example, apply is null into either data frame or a data series to filter out the null data or drop them or fill them with a certain custom value. We can do grouping aggregation, so we're going to have, if you want to group some information and calculate an aggregated average over a certain number of columns, that's also possible. And it allows also to merge and join different types of data frames. So to compare with other tools, so many of the things that you can do in Excel, they can also be done in Pandas, either data frame or series. But you may ask, so why do we need this? So first of all, in Python, everything is programming, so you can write scripts. Although in Excel, you can write scripts in Visual Basic, but you have much more freedom and flexibility in Python to write more powerful and automated repeatable frameworks by considering all the advantages of the Python programming language, and also allows you to handle larger data sets. Now, when you open an Excel file, if you have a large amount of data, it's going to spend a lot of time to load this data first. And any kind of operation that you will do, especially if you write long scripts, they are going to be very, very slow. So with Python, this is more flexible and more efficient to work with larger data sets. So same thing, you can use Pandas to load data from SQL databases, and you can do also SQL queries on this data that comes from SQL. And also, so Pandas built on NumPy, so it inherits all the different advantages like high performance computing from the NumPy. It's a high level API on top of NumPy that is designed and conceived for data wrangling tasks and data analytic tasks. So Pandas is a third party library, so you need to install it. It doesn't come by default with Python, and it's pretty much simple. pip install Pandas or conda install Pandas if you use conda distribution of Python. And it works only from the version 3.7 and above. Now we are 3.12, so it should be fine if you install the default version of Python. But if, for example, for some legacy purposes, you need to work with 3.6, Panda is not supported. And this is how we import Pandas usually. We import Pandas as PD, so we make an acronym. So later on, we can use pd.dataframe to create a new data frame, or pd.series. You can do import Pandas and pandas.dataframe or pandas.series, that's also possible. And after installing Pandas, you can check its version by printing pd.__version and __ here. And this ensures the latest and correct version is installed. So this is from the installation perspective. Now the first type of Pandas data structure is called the data series. So what is a series? As already mentioned, it's just one-dimensional labeled array, which is capable of holding any kind of data types. It's similar to column in a data frame or just one-dimensional array in NumPy array. Of course, we're going to have NumPy later on, but it's basically just it's one-dimensional vector where you can store data. It has an index, so you can specify an index. And the index can be row labels, A, B, C, D, for example. And it can support heterogeneous type of data. So you can store here integers, floats, strings, or even objects. Okay? And supports vectorized operations. Of course, we're going to talk about vectorization when we talk about NumPy arrays. It's a very important property that allows you to make manipulation of these data structures without needing to make a for loop. You know, a data structure is a collection of values, right? So if you want, for example, to make the sum, usually you need to make a for loop going through the elements and calculating the sum of data structure. That's the typical way. And it turns out that this way is not really efficient when we do, when we process large amount of data. So this is why Python data structure introduces the concept of vectorization that allows you to make manipulation on data structures. You can take an array plus another array, so it will be calculated without requiring to make a for loop and going through all the different elements. And this is what we call vectorization. We're going to have a complete discussion about vectorization with NumPy array. And this property is inherited from the NumPy array itself, okay? Because all these data structures are built on top of NumPy array. Is it clear? I'm not sure I'm talking fast, or are you able to follow? Okay. Yeah.
Just one question. What's the difference between NumPy arrays and the normal arrays in Python?
Yeah, NumPy arrays were designed for optimizing the computation efficiency. Okay. Yeah, and they are basically defined in C++ or in C, and there is a wrapper layer in Python, and all of this to optimize the computing performance. Because now most of the deep learning framework, they are based on NumPy array, and they manipulate a huge amount of data. So if we don't optimize the computation, we're going to spend even more time processing these data for deep learning and machine learning algorithms. Okay, so creating a list is pretty much simple. There are different ways on how you can create a series. You can convert a list to a series by doing typecasting. pd.series, this is creating an object, and in the constructor, you will put a list or an iterable, and then it will convert it to a Pandas series here. And it will assign default indices. So the index is by default 0, 1, 2, 3. It's integer index, but you can change it. Okay? For example, here you can create a series from a dictionary. In this case, this will be considered as the index,
ستحتاج
and
إلى
this
فتح
will
قفل
be considered
الآيفون
as
أولاً.
the value, okay, that corresponds. So index is derived from the dictionary key. You can also create it from a list with custom index. Okay, so this is the list, and you can create a custom index and provide something different from the integer indices. Okay, and this indices allows you to access a certain element. Okay, and also using NumPy array, we can create a NumPy array np.array, and this is a list, and then by doing also calling the NumPy array as an argument of the constructor of the series class is going to convert it into a series. And of course, the NumPy array should be one-dimensional to match the size of Pandas series. You can create it from scalar vector as well. Okay, so scalar vector, and you specify index. So what will create here? It will create a series that contains the same value and repeated 4 times. And you can create it from another series. So this is an original series that we create using a list, and then I can also put in the constructor. So the constructor accepts different
حسناً،
types.
عثرت على ذلك على الويب.
I don't understand what's going on here. How? خلينا نطفي الجوال الحين وبعد نشوف. It's talking every time. And it's only during lecturing, I don't know. It's like listening what I'm saying, following the lecture. Okay. Yeah, and this is how to access. So if you specify the index by a label, so you use that label to access that element. And if you don't specify, so if you put the integer default position, in this case, you will just call it by its position. And also you can do slicing, like we do with lists and other data structures. For example, this retrieves the subset of the series between position 1 and 2. So including 1 and 2. 3 is exclusive. So basically this is a rule in Python. When you have an AND index, it's always exclusive. It's not including into the filter. Yeah.
How to find the index?
These are the 3 ways.
This finds the element using the index.
Yeah, either by a label, if you use label for indexing, or by integer, if you don't use, or you can do slicing.
This finds the value, the element stored at that index. How
Yes.
to find the opposite, the index using the element.
No, you cannot, because the element can be duplicated. So you cannot identify a key from a value, but the opposite is true. Okay, so slicing in Pandas series, extracting a subset of the elements from a series on index position or labels. And we can do that, for example, using the start index and the end index. So 0, of course, is the starting index for the elements. And if you use slicing by labels, if you use labels, you can do it between index A and C. Okay, elements return all the elements between A and C. And here we assume that they are ordered. Okay, there is a logical order from A to C. And slicing with the steps. So here we slice from 0, retrieve every second element. So here, when you specify another number, this means the steps, how many elements you jump. Okay, so between 0 and 5, retrieve every second element from index 0 to 5. So it will return 0, 2, and 4. So this is for series. Now data frames are the two-dimensional structure, which is also labeled data structure in Pandas. It contains rows and columns, as already introduced, and similar to a table into a database or an Excel sheet or a CSV file. It can take heterogeneous type of data supported across different columns. So the size is mutable. I mean, you can increase, you can add elements, you can remove elements. And it's labeled the index of the rows, and also there is the columns. They are called the headers. So we define headers as a column, and then each row will contain one record. Okay, each record is defined over a single row. And then you can do multiple operations like filtering, grouping, reshaping, and this is what we are going to have. So there are different ways on how to create a data frame. You can create it from a dictionary like this. So this here, the key, and this is the value, and this is going to load it as like a table. Okay, it has two columns, and this is an element. This is the first element of the column, and this is the second element of the column. So here it's going to create two rows. The first row, the name is Alice, and the age is 25. And the second record will be Bob, and the age is 30. We can create it from NumPy array. Please don't use your mobile phone. I see many people using mobile phones and not following. So the second way is using NumPy array, same thing. And you can specify also the columns, how many columns. So here we have, you can give a name to the columns, column 1 and column 2. So this is going to create two columns and two rows as well. Require accessing the column name explicitly. So this is an option that you can add into the constructor of a data frame. Of course, there are multiple options, but for the sake of simplicity, we introduce the most important elements. And also, it's possible to load. Okay, so it's possible to create a data frame also from a CSV file and an Excel file by reading. We're going to have this more in detail. To access data into a data frame, so you can access by the name of the column or the label of the column. Imagine that you have like a table and you have the name of each column. So you can specify, this will specify a whole column, all the data for, so that be converted to a series, or you can also select two columns or multiple columns from the data frame. Because usually when you have a data frame, it may contain information that you need or other information that you might need. So you can filter out what kind of columns you would like to process in your project. So this is the access by label, and there is an access by the position, okay, by the row. By the row, there are also two ways. You can access by position using iLock. It's by index, the location of an index. So this means it's the first row in the data frame. Using iLock, and then we put the index of the row. Or just .lock, and here the row label. Okay, if the row has a label, we can use .lock to select specific row. So this is how we can select columns, and this is how we can select rows from a data frame. So let's talk with this in more details. There are two types of indexing. within DataFrames. There is the label indexing and the integer indexing. So the label indexing, we use the lock. It selects the data by label or a conditional statement. So this will access the row by a certain label, okay, the label of the row label here, .df.log. So df, this is the definition of the data frame. We created using pd.dataframe from an array, or we imported. So this selects specific column by label. Okay, here we're going to specify a column by its label. This is equivalent to this one. Okay, but it's just another notation on how you can access it. And most importantly, and this is something that is pretty much used in data analytics, is by using conditional selection, and this will filter out the data based on the condition. So that's, what does it mean? We're going to select the rows, all the rows that satisfy the condition age is greater than 25. You have many rows that contains people, so I'm going to take only people that are with age above than 25. Okay, this is pretty much used when you do, for example, you want to do your data analytics over a certain population age. Okay, yeah.
If there is no one above 25, what will be the data?
Nothing, known. Okay, it will be known. Okay, and using integer-based indexing, you use the iloc and select the data based on the integer position, accessing rows by position of the column. Okay, this is the index of the column. So this means the whole first column. Okay, so this selects all the rows of the first column. If I want to select the third column, I'm going to put the index 2. Okay, so you can specify the index of the column, and we'll select all the rows. Retrieve the first row and select the range of rows and columns. This select only the first row. But if I want to select a range of rows and columns, we can use multiple indexing. So this selects all the rows from 0 to 2, and this selects all the rows or the columns from 1 to 3. So it's going to take like a subset of the data frame. Clear? Or questions?
Clear.
Not confusing, because sometimes people get confused between iloc and loc.
The iloc index loc with the
With the label, bas. ممتاز.
Because 0 and 3 are inclusive.
It's always the start index is inclusive and the end index is exclusive. This is a rule in Python for any kind of slicing and indexing.
For the look, how can we put a label for the rows?
For what?
For the rows, how do we put a label for them?
No, for the lock here, it's only by,
Column?
so select the column, yes. Yeah.
Can I display the data frame correctly after I do some operations?
Yes. There is the df.head. It shows you the first 5 records of the data frame. Yeah. And first I will introduce you the concept. I will make a practical session where we review this and we see this in practice. And I used to do everything coding. It has pros and cons. You can see everything, but you will not memorize or you will not recognize the concepts. So I want first to introduce you the whole landscape, and then we're going to apply it. Okay? Because there are so many concepts, so I want you to have structured information about these data structures, and then it's basically a syntax, syntax, we can find it everywhere. Okay, so data importing in Pandas. How can we get data from data sources? So you can import the data, or you can read the data from a CSV file. It's basically the same way, either from CSV or Excel is the name of the function that changed. So we're going to use read CSV. It's going to return all the data from the tabular CSV format. And CSV is like Excel, but it's text-based and has a delimiter. And delimiter usually it's a comma or something different. So pd.read CSV is going to load all the information in data frame, and then you can do data manipulation. And there are also some common parameters. For example, if the separator is not a comma, you can specify the separator. Sometimes you import the CSV into Excel and tells you what is the separator, or when you import the text file. So the separator will delimits what's the it's the separation between one record and another, okay, an element and another into a CSV data file. You have header, defines which row is treated as the header. Usually the header by default is the first one, okay, it contains the name of the columns. You can specify index column, set a specific column of the data frame index, and also you can read only specific columns. If I don't want to import everything from the data frame, I can specify I want the column name and the column age. These are additional parameters. Usually we import all the data and then we can do filtering afterwards. So same thing with Excel file, you know, it's just the notation that changed. We can do exactly the same thing. One of the differences is that Excel can have several data sheets, which is not the case with CSV. So here you can specify which sheet name you want to import. If you have multiple sheets, by default it's going to import the first one, but if you want to specify, for example, the second, the third, you can specify it by the sheet name. Okay. And there are additional parameters like the skip row. It's going to skip the first two rows if you want. For example, you don't want to import the header columns. You want to import maybe sometimes you have comments or the name of the columns, you don't want to import them. It's possible, it's a parameter. By default, it's 0. We're going to import everything. Or you can specify which columns you want to import. For example, this is column A to C only. You're not going to import the whole data sheet. And you can combine all of them. You can, for example, put sheet name equal sheet 2 and user column is equal A to D, for example. You can put all of them.
How do I import two separate regions or columns? Let's say if I want to import from column A to C.
I need to see, yeah, there should be a way. Maybe you will use a different type of slicing here. I'm not sure whether there is a dash, but probably it's possible. Yeah, or you can import different data frames and then merge them together. That's possible also. Yeah, Python syntax is very rich. I mean, it's difficult to know. I think there should be a possibility, but syntax-wise, yeah. You can do the same from SQL databases. Okay, first of all, so the rule of thumb here, you connect to a database, so you get a connection object, and then you use this connection object to do SQL queries. Look now, read SQL, and then you can send an SQL query to this object, which is the driver of the database. This is the context of SQLite. Same thing for Postgres and MySQL database. You create a connection. Of course, every type of database has a certain library in Python, so you need to pip install the library. For example, here you pip install SQLite 3, you import it, and you create a connection. Okay, every database has its way to create a connection. Usually use .connect from the important module, and this is the credentials to access the database. And after you access the database, you can just query the data, and this table is going to be important as a data frame, and you can do all kind of data manipulation. You can do also other parameterized SQL queries on that. Finally, you can read the data from JSON files. So read JSON data, it's going to import it. But there are different ways because JSON can come into different formats. Like, for example, some JSONs are structured as a list of records of dictionary. So this is the default structure of a JSON file. This is the expected. In this case, we use the orientation parameter as records. So by default, it's records. And when you put it as records, it's going to expect that the JSON format comes as a list of dictionaries. Now, another parameter, if you use index, is going to consider as a dictionary of dictionaries. So this is a valid JSON format, and this is also a valid JSON format. But the way on how to parse them and import them into a data frame will differ. So you need to specify the correct parameter to make the correct import. Is it clear? So This is another common JSON file structure with every record, every dictionary is in a different line. This is called a new line delimited format. So in this case, you can use lines equal to true. And this will load this type of parameters. So without spending a lot of time here, they are just syntax to export. Now, after importing, you do data manipulation. You want to save them back to the files. So you can export them to a CSV. You can export them to an Excel. You can export them to an SQL. And you can export them to JSON. Okay, it's basically a syntax. There is nothing to explain more. That's pretty much it for today. So tomorrow we're going to continue talking about data frames and the most important operations, like how to make data manipulations and